I don't want to call him out by name, but a lot of people think you failed algebra 2 when they do. So again, they're not going to move you just because you failed algebra 2.
I felt
Yeah.
I felt second semester algebra.
So we have other sophomores in here. That's not an excuse. Actually, if anything, a sophomore in here should be a stronger student. It means you get math. So that's not an excuse. So they're not going to just move you out because you're not trying. I mean, you've literally never taken a note, dude. So I'd like to see the notes you've taken, probably from the 3rd day of class. Yeah, so that kind of, again, emphasizes my point. Where are your notes? In the trash. Hello. Again, I would love for you to just actually try. This stuff is not that difficult. What we just did, not that difficult. I mean, the lesson was yesterday, so you would have had to have paid attention yesterday. All right, so really quickly for the recording. So we did a problem where we had different bases. We had to convert the 27 into the same base, which meant we had an exponent of 3. Then we multiplied using the power to a power rule. We multiplied the exponents that are highlighted in yellow. That got us to the 6x plus 3 over on the right. So here, since they don't know what I'm talking about, that got us to this over here, which got us to that, which was the equation, because if we have a base of 3 on the left and a base of 3 on the right, then the exponents have to equal each other. So now we're getting to that was actually yesterday, but so here's your new problem. Again, this is going to be quiz. I told you there'd be one like this. So your investing 10 should not be difficult. Nothing about this one's difficult either. Investing $10,000. You start when you're age 15. You retire at age. Oh, wait, I'm sorry. No, I know. Well, you start saving it at 15, but you will invest it at 25. So you're 25 years old. You retire at 65 years old. And we'll say your average rate of return is 9%. You're figuring out how much money you'll have when you retire. From that 10,000, like not including anything else. We did this already. It's a formula. If you don't know the formula, I'll put it up there in a minute. I want to see if anybody can intuitively remember the formula. We're actually using a different formula today that is a version of the same formula. You're going to see it there in a minute. With one small change. And we're going to learn what the variable or the number E stations for. Where that comes from. Because you do E and
No, I didn't.
and algebra 2.
Yeah, I can't do this. Not posted. I'm gonna do it at not.
Well, we're not doing average. We're not creating an equation. There's no average rate of change because it's exponential. There's not an average rate.
What is the average rate of return?
9%.
No, I'm saying the word. I got that.
Oh, to the left. Yeah. I'm sorry. The percentage isn't at like because the stock market goes up and down, right? So you're not going to get 9% exactly every year. I see what you're saying. So I just said we'll just say on average for those 40 years, the return is 9%.
Like every year is.
Well, that's what the average is per, right? That's what average means per year.
Yeah.
It's really a rate of change per year. But again, that doesn't mean you got exactly 9 every year. Yeah.
There's different outcomes. It might be higher, it might be lower. There's just the average.
Yeah. So if we just calculated it out based on, well, what if we averaged all the years out, what would it have been?
I think I got it.
It should have been around 350,000. Lower? That's too high. Because we did 9% instead of 10%. Drop it. And I think we did did we do 15,000 or 10,000 we did it? Yes, right, 10,000.
10,000.
I think we did, but we also did other numbers too, right? Just like,
I get it. No,
it's like changing it, I think going from 10,000 to
I know.
15,000, it gave us an extra like almost $300,000.
Dad to say, oh, that'll be hard for if I did that.
I don't
Oh,
know.
God, to make your heart full.
Put our last name on the back.
But that's fine.
Absolutely not.
Oh, I was gonna write the formula. So here's your formula. So the money, I guess, that you have after 40 years is the initial investment. So P would be how much you borrowed, if you're borrowing money, how much you invested. So we talked about buying a car, how much you borrowed would be for like buying a car or a house, I guess, when you get much older. Times 1 plus, let's see, how am I gonna write this? I guess if we're using it like that, we'll say divided by 100. If you want to use the rate as a integer, then you have to divide it by 100 and then add it to 1. And then you raise it to 100. So now try to correct. What number did you get, Hayden? Yeah, so that sounds about right, because I think we did it yesterday with 10%, I think like 365. The initial investment, so the 10,000. Or when I say investment, it could be the initial amount you borrow if you're talking about paying a loan back.
What about 40?
Not times 40. 40 is an exponent, but multiply by 40.
That doesn't.
Yes. Yes,
Didn't
it's
work.
just math.
Times.
Didn't work.
Man, I thought this was gonna be easier than this. Right there. What did you?
I did.
Did you though? Then you're doing something wrong in the calculator. So what'd you get in the parentheses? Got a voucher. How long have you got a voucher? This will be one of your easy questions on Monday.
Yeah. This idea.
Not exit ticket, Monday. Exit ticket is the other one. Exit one.
Bro.
No, hey,
It's not,
well, we did a second.
I literally just put the
But-
equation.
There will also be one of those on the quiz as well. It'll just be
It's not gonna.
changing both.
What about logs?
I do.
Yeah. That's what we're gonna get to today and Thursday. We'll probably not do tons of it today, because I'm gonna review like stuff that's very beginning of the mistakes. And skip the whole thing, assuming you're a first point with log, or we're gonna go back and very beginning stuff with log. We'll see how far we get. You get it?
No.
What?
I only put it in the calculator.
What did you get in the parentheses?
What?
Like, what's this part? What did you get?
1.0
Yeah, so 10,000.
times 1.09 is a pound of 40.
Oh, it's 0.0.
Well, you gotta add that to 1 though. So that's what you should have, right?
Yeah.
So again, the calculator will handle it, but I like to just make sure and do this first. So do that. 1.09 raised to the 40th. It'd get what, 3.14 something?
3140.
Bro,
Did you get 3.14 or something of them?
no.
What? Are you using the wrong button? What are you using to raise the power? Are you using the upside down beat?
Yeah. What is it?
Oh, you already multiplied it times 10,000. Yeah.
See what happens when I got it? Right?
There you go. Well, a lot of the stuff we've done has just been algebra, hasn't even been algebra, so do it.
Oh, no, I also did the four-point company.
I might have enough of the green ones, since people like the green ones.
I haven't done anything else.
Funny how I just like. It's just.
Yeah, because I like, when I don't know initially how to do a problem, like I was.
But you literally, you're just doing, now you just have to do calculate. I was gonna say, there's no more figuring out to do. You're literally punching numbers into the
Yeah,
bracket.
I physically don't have the thing.
All right, so. That will be on your quiz, and here's the next piece, which is gonna possibly get confusing, because it's similar. So there's this thing called compounded interest. Ever heard of that before?
Yeah.
So it's not really around as much. I mean, it is around, I guess.
You have a worksheet for this?
No, it's just, this is from the book. Let's- So this is, you can just look at example 8, page 366, example 8. So we have assumed that the interest is an average rate of return per year. But if you invest money, sometimes they'll tell you a specific rate you're going to get, and you're going to get that every single time period that they do what's compounded. So here's what compounded is. If they tell you we're going to compound something annually, so again, you would never get that rate 10%. But I'm showing you how this would work. Well, actually, we'll do 9% since we already have those numbers. What happens is you take your $10,000, right? And they say, we're going to give you, and again, you would never get this number, but just to match our numbers up there, we're going to give you 9% compounded annually. What that means is they're going to give you the percentage at the end of every year. You could put it in January 1st. At the end of the year, that's when they give you your interest. It's realistic. Oh. Oh, you're talking about the rate.
Yeah.
Yeah, I really don't know what rates are at these days. So they're gonna calculate, so this is what you gave them, your principal. They're gonna then, at the end of 365 days, compound it, which just means they're gonna pay your interest at that point. Your first interest payment. So you can multiply that out, pretty sure it comes out to be that.
Yeah.
They add those two together, so at the end of 1 year, you got that. Well, no, this isn't, you give them the money and they're giving you interest. So now
$9.
this repeats again. So now you're on your second year with them, but now you started your second year with that. So you say plus, oh, so this was our interest, right? Our interest was the 109. But the second year we started with more money. Now somebody's gonna have to do this on the calculator. Oh, wait, they're not. Yeah, you are. So multiply that, 1.09. So again, 365 days after the first 365 days. What's that? Just round it off to the nearest dollar is fine. It shouldn't be a whole 120-ish. Well, just what is, I want to know just this,
Yeah.
1.09 times. Oh, wait, then I did the wrong number, so hold on.
This puts you at well over 11.
Yeah, I only want, yeah, I see what I did. So I just want the interest, so yeah. I didn't catch that. We are just, I want to show you just the interest. So for this, we don't use the one actually. And we're just, so yeah, 0.09. So what did? Well, I can do that math. So that would be 900.
Yeah, because you're multiplying by.
Because yeah, 9, and I'm taking 2 decimals off. Boy, I wouldn't have thought it would have been that high, but gotta be right. Just make sure somebody do 10,000 times 0.09. That's gotta be right.
Yeah, 909.
Is it 909? No, it can't be 9. No, this one up here, the very first one.
Oh.
So that'll be the next one. So 9. So yeah, so that's right. So the next one, if we do this one, is 9. I'm just gonna round it to 910. So that's what we have. Oh, but then no, I'm sorry, we gotta change it though. That's my fault. So now do this calculation. 0.09 times 10,900. So 0.09 times, because that's what we started. We should have started with 10,900. Beginning of the
There you go.
What'd you get?
90.
Say it again. 981. So now we add 981. So again, first year they paid us 900 because we only had 10,000 to start. But now they paid us 981 because we started with more money, which means our interest was higher. So this is how an exponential equation works. Every year, you don't, a linear equation, we would have gotten 900 every year. Because that's what we put in, it would have been linear, 900 is your every single year. This represents a model that is exponential. It's going to have a curve to it. So the farther out you get, like eventually we're going to have a gigantic, well not gigantic, pretty big interest payment. We'll do one more. So now I want you guys to figure out the 2 pieces. I'll give you this. What is that? 1, 1. 8, 8, 1, I think. So I want you to come up with the next line. So you'd be coming up with what we had basically here. Here. What did we start with?
What did you just say?
Mostly.
I know.
And you should see the interest payment again went up, but it went up by even more this time. Instead of going up $81, it'll go up by even more. So it's not only is it not the same amount every time, it's actually the increase in it is bigger every time, which is why it's exponential. That's why there's a curve to it.
Wait, is it supposed to be 1.9? 1.09?
Well, we're just figuring out the interest and then we're manually adding it back on.
Oh.
If we do the 1.09, we wouldn't need to add them together. We would just multiply them. But we're like showing the breakout of how all of it works. So what do we start with? I mean, you should all have what we start with. So what is our beginning? So beginning the 3rd year, how much did we have to start with the next? Yeah, we had what after we added the 981. And then we're adding to that the interest, which would be what? Calculate. That one. So should have been 0.09 times 11,881. Is that what everybody got?
Yeah.
What was the number again? 10, is that right? 1069?
Yes.
All right. So when we add, so what'd you get when you added those together? 12,000. Say it again.
12,900.
2? 12,902?
50, 50,
12,950 or 52?
50.
Is 50 even? All right. Oh yeah, I could have done that.
That's 1.9 cents.
So now again, somebody do this for me. So the first year, the the extra was 81. Subtract these two. 1069. How much extra we get that second to third year? 1069 subtract 981. Somebody do that. So this number subtract this number. So again, the increase, right? First year we got 900. Next year they paid us an extra 81 over the 900. Now they paid us an extra 88 instead of just 81. So not only are we getting more than just the 900 every year, the amount that we're increasing it every year is also getting bigger. That's what exponential is. That's what having going viral means. That's what when you talk about like, that's like when you hear scientists talk about something, decay or exponential growth in bacteria, like all that kind of stuff. All that stuff has to do with exponents.
Like virus.
And that's literally where the word viral comes from. Is yeah, virus increases at an exponential rate. All right. So again, the main thing you just have to know how to do though is this piece up here. So now I want to do something a little different. And we'll kind of be able to see what if instead of giving us the money at the end of every year, what if they actually compounded it twice a year? So they're going to say, well, tell you what, instead of waiting 365 days, we're going to pay you your interest every 6 months, we'll say. Now they're going to split the interest in half, where they're not going to give us a year's worth of interest. So if our rate is 9, I wish I would have done this in a spreadsheet. So we're going to start with 10,000. Start with 10,000. I'm going to do the first one for you. So just kind of watch. And then we say, all right, well, to that, I need to add the interest, which is 0.045. Because again, it's only a half year worth of interest. I can't get a full 9% when I've only gone 6 months. So I split the 9% in half. And then that would be times 10,000. And then figure out what that equals. So again, this is halfway through the first year. So how much do we have? Pretty sure you should get that.
Yeah.
Get it?
Realistically.
Let me wrap. Actually, was somebody waiting for him?
Kind of good for some.
Because
I don't want to stop the calculation. That's I was going to do that. I want to show you what compounding it more often does. So now tell me what you'll have at the end of the first year. So calculate out. So we did have, this is half a year. I want you to tell me what we'll have at the end of the first year if we compounded it twice a year instead of once a year. Kind of just going to do it. You should have the starting number. It's the same sort of thing we've been doing. Again, if it's half a year, another half a year, we're only using 0.045. Just calculate it out. Equals. So I got 10,920. Is that what we got?
Yeah.
So what happened when we compounded it twice a year versus once a year? Got more money, right? 20 more again. So if we kept doing this, and let's say we compounded it 4 times a year, then we'd have even more money, right? And then if we did it 8 times a year, if we did it monthly, 12 times a year. What if we did it daily and we did it like every single day they paid us our interest? We would really start to build a lot more money fast. Turn to page. So that's part of the concept is again what compounded interest means. Turn back one page.
You have, sir.
Did you ask me that earlier?
Yeah, so.
Oh, what? That was a random another. So 365, look at that little table on the left. They keep changing how many times they're compounding it. So they started with once a year, then 10 times a year, then 100 times a year, then all the way down to 10 million times per year. Eventually you get to a number that it is changing a tiny, tiny bit, but it's not really changing. You see that little letter E right there? Like below all the numbers on the right. See that letter E? I need your calculator.
I don't like the booklet, inspires me.
You did that though before, right? Did you do that, you remember, in Algebra 2?
So,
E?
maybe.
It doesn't work well. Open over your calculators. So E is like the natural law, like it's just a constant, it's just a number. Now it's a number that doesn't repeat, it goes on forever, it will never have the same pattern coming up, even though it kind of looks like it in a way. It comes from what we just did. There's a mathematical calculation where if you said, well, if you were like compounding every single instant that passes, you were compounding the interest. Like as soon as an instant passes, you're compounding over and over and over again. If you add all that interest up, it gives you this weird value E. We're not going to do a whole lot more with it. I'm not going to even do anything with logs with it, although it might. Now, I just wanted you to understand all E is a constant. It's just a number. Comes from this specific concept of compounding interest. It's used in finance. If you ever wind up going into finance, you probably will run into that. So if you don't want to run into it, don't go into finance. It is kind of a big deal in the financial world. It says right there on that page, continuous compounding. I'll be honest, I don't really get why it's that big a deal that this happened, but apparently it's a big deal in the financial world. What you're going to need to know how to do is if I give you a problem and I say compound or compounded annually, it's that formula. Okay, so compounded annually, that formula. If I then say compounded quarterly, what is quarterly? How many times a year? So your formula just changes to this. So your money is the present value. Let's see, how am I going to write this? Well, hold on, there's a little more to it than that. So 1 plus, how do I write this in formula? Yeah, right. We have to divide by 100. That's the problem. Oh, here we can do this one. It's going to look weird, but. So all that R divided by 100 means is you need to take 9% and make it 0.09. We're just, that R divided by 100 is just converting it to a decimal. That's all that means. And then that's the key up there. If you're compounding it 4 times per year, then you got to multiply the 4 times the number of years. That's why you have so much more money. Your exponent's going to be a lot bigger because you're multiplying it times another number. How many times per year you're compounding? that's because we have to divide the rate, whatever our decimal is. We have to divide that. We can't give ourselves a full year of interest if we're we're giving it to ourselves 3 months in.
Also added time.
We'll multiply, that's multiplied, right? NT is N times C. I'll probably give you both formulas and you'll have to know which one to pick. I'm not gonna make you try to memorize them, so just as long as you understand the difference. N means we're compounding the money more than just once a year. 4 times a year, 12 times a year, I may just say twice a year. So that would be the formula you'd use there. Again, not super complex, as long as you understand what that variable means. I'm not gonna go over it, but if you wanted to know anything about nuclear waste.
No.
No. So nuclear waste has what's called a, well, actually, I'm sorry. This is specific to plutonium. I guess I shouldn't say all of nuclear waste. It's probably different for them, but look at that formula at the top where it says 367, where it says radioactive decay. This is why nuclear waste is bad. A lot of reasons.
Like,
Chernobyl was the big one. That's what this thing is about. Wait for your time. I don't get you. If, of course, hopefully you all know nuclear is bad for you, like nuclear energy, if you're exposed to nuclear stuff, not good. But the other reason it's bad,
Energy is the radiation.
well, the radiation, yeah. But I mean, that's what I'm saying, if you're exposed to
Radiation.
the whatever, then the radiation.
radiation.
But it's the material that this equation is talking about, so the plutonium. If you have, what this equation is saying, if you have 10 pounds of, again, this is about plutonium, I'm sure they're probably all pretty similar. It has what's called a half-life. You see that little exponent? 24,100. See where it says that? T divided by 24,100. That means in order for half of that plutonium to go away, to decay, it's gonna take 24,100 years, just for half of it to go away. So this decay problem, you can figure out after a certain number of years, how much would be left. Well, again, what's that?
It's a biology.
Yeah, I mean, all of this stuff is science related. Like if you were doing forensic sciences, a lot of they do decay of what is carbon dating and all that kind of stuff. Like I'm sure they're using this kind of formula, like how fast does carbon decay, figure out how much carbon we know in general, how much the human body has, how much does decay. Like I'm sure this, I don't know this for a fact. You do, if this is what you do. It's the same concept, I'm sure. I don't know what plastics are. They're not good though either. Yeah. So I'm sure there's an equation for different plastics. But this stuff is definitely science related. No doubt about that when it comes to decay and growth. When it comes to, like I said, how fast does bacteria, viruses, that kind of stuff grow. All right. So that's all we're really going to do. The only problems you have to worry about for the actual quiz. Like I said, probably 2 of these, one with compounding annually, one with compounding more than annually. You need to know how to do that exponent stuff we did before, 21 through 24, and that's really it. So now we'll go into logs and we won't get too complex. Probably. That. I want you to turn to page 3. Wait, let's see if there's. Oh, yeah. Look at example 1. I want you to come up, will they give you the answer? They kind of do. Well, that's fine. Look at example 1, 371. I want you to read that and see if you can figure out what a log is. They give you all the answers. They worked it out. You can go straight to the solution. I want you to be able to explain to me what a log is. That way you can fake me out and get it up fast enough where I can slide it.
A little bit.
Yeah. Yeah, so I knew I didn't need to. I knew I didn't need to. Hmm? Oh, yeah, no, yeah, yeah. Here, just take half a half. Oh, no. That's right into your phone once. You got zero reaction on that.
Is it?
You were so into your phone. Yeah, like 4 seconds after I said it, when you finished your phone call. Well, whatever.
Yeah,
Even worse. That doesn't make it better.
Oh, I love
All I have are these.
I love them.
Yeah, I haven't even looked in the store to see if they're going. A lot of people. Going to these.
I love how
Is
Rachel.
it like these?
I what do you want?
Okay,
These?
you want that?
Yes.
Actor.
Yeah, I haven't even looked in the store to see if they're allowed to sell the other one. Going.
My dad,
That's yes.
What? The other ones that. Oh, these. I don't love these, but I mean, they're all right. I'll eat.
what are they? Oh,
They look like oats and grain, like just no chocolate. Basically.
oh no, yeah, he eats those.
Yeah, I don't think they're bad.
They're just best.
No, he eats them with the milk.
Do you want one?
From the, I didn't.
And we're done.
He also has the.
All right, so can anybody explain to me?
Hey, what problem we're doing?
Well, we're looking at the example, and I don't care if you look at the problem and the solution, and I want you to explain to me what a log is. What do you think?
No, blanket.
There's actually more in that community.
Thinking of car shop.
It does have to do with exponents, but it's not an exponent, or else we wouldn't need exponents. It's related to them, but how would we explain what a log is? If you need to give me an example, give me an example. It's a what? Take an X, plug it in.
I'm doing close right now.
I was gonna say the rate at which.
I don't know about that one. I wouldn't say it that way. It has to do, think of, how does it relate to exponents? That's the key. How does it relate to exponents? I don't know if I think it is.
Changes it,
I do
right?
believe it is kind of the inverse of exponents. So let's do this. What's that? And we know there's a 2 here, right? If there's nothing there, there's a 2 there. That's 4, right? So again, that's what we get. What about this? I don't like that.
3.
Yeah, I don't like that. Now. 5, right? We'll do this one, even though we sort of have done it. What's that? 10 is kind of a special case for them, so that's why I wanted that. How could we write these exact same things, but in log notation, using, logarithm notation? So look at the book. They give you probably some of these exact same ones. No, we're on number 8.
What example are we on?
We're on the next chapter, girl. 371. Example 1.
Oh. Nobody told me that.
Well, except for the fact that I said it 3 times. See what happens when you're playing games on your phone? Imagine that, you miss stuff.
I like my game.
Yeah, I'm sure you do. I'm sure we'd all love to be playing games. I would love to be hitting golf balls right now. Oh, that's not good. So again, they give you some examples and they show what they did. So how could we rewrite these? I'll write them in red. How could we rewrite these using log notation? And it is still called the base for part of that reach logs. Yeah, base. I mean, they tell you right there where it says definition of logarithm too. Actually, yeah, they tell you exactly right there in that one, definition ones. But if you understand this, granted, logs get a little tougher, but at least if you understand the concept, it won't seem so weird. Foreign. How do I write that top one? Oh, don't forget too, there's no retake on Monday.
Oh, I brought it there. Then I know it.
All right.
Wow, we've been paying attention.
Hmm?
We've been.
Yeah, but this, well, I got a lot of people not really doing some stuff right now. But again, you are actually legal. She wasn't even on the right page.
Listen, I wasn't on the right page and I know what I'm doing now.
Do you?
Yeah. Right?
I don't know. I'll ask him.
What's that?
So it'd be 4 to the exponent of 2. That's, yeah, 2 words.
So, but here's my question. Is it 4 to the exponent of 2 or 2 to the exponent of 4? It's
So,
actually the same answer, so that one's a little easier. Do the next one. That one will tell us.
or actually, it's, oh, yes, it's the wrong way.
So log makes me.
I couldn't figure out which one it was.
No, it's gonna be log.
Now,
and
the
then
trick comes in is
equal to.
with logs, when the exponents are decimals, it's easier to use logs. Then you can't really, you can only really use exponents when they come out with a nice round exponent, not with the exponent of the decimal. But with logs, we can figure out answers when the exponent figure.
You're right.
Oh my God, what are you doing to my record? But
I hate this thing. It's so annoying.
Oh my goodness. You have to come up with an easier way to get this.
This one's answered next to the.
Oh God, my bracket came.
So I was right.
No, it'd be log 4 and then 2, 5.
Order egg.
Oh, your answers are X. Okay, yeah, you're right.
Yeah.
It works either way.
Well, it doesn't work. Well, it might work for one of them either way.
No, it works. I'm just saying it works for the top one either way. But she was right.
Mm, I think you got one wrong in the second. Second. Gotta fix the second one. Nice, if you want to correct it, better know that you got a different answer.
Listen, I stared at that paper for a good like 3
And as
minutes.
soon as you walk away from the paper, now you lost.
No. I know the concept
You're
of it.
wrong. But you gotta be able to, again, the concept is great. 100% positive about that one. Look,
You told me the first one was wrong, so this is the only other thing that would make sense.
is it?
Yes.
Is it real? So
Because the
explain to me
log-
what it means. Explain to me what it means. What's the log mean?
I
What are
need
you
a
doing with
pointer.
those 3 numbers?
I don't like that you have not. I need a pointer. Give me the yardstick.
I used to have a laser pointer that I can shine. Battery
I
died.
don't think it, honestly.
So
So,
go to the top one. So how's that work?
so
3 to the power of 5.
yes, 3, 5 is 125. That's why 125 cubed is 5.
I love how confident you are in that right now.
I don't like your condescending tone.
I just love it. I just love how confident you are. So explain the top one.
3 to the.
I love how confident. So let's explain the top one.
The top one, I have food in my teeth. You take the, like, whether or not you're squaring, cubing, whatever, and that's your log. Right?
So you're saying the root becomes your log.
Yeah.
Hmm.
Go sit down.
That's fine.
way. I was getting there.
Were you?
Yes.
Mm.
Good. But
So rewrite it.
oh, you have to recalibrate your thingy. It's lagging.
It is slow. I do that like 100 times. There, oh, almost.
Oh shit. Use my bottle now.
Ah, that's better.
There. Okay. Yeah.
So go ahead and explain now. It looks-
Okay. Well, that means this one's wrong too.
No, because it works both ways in that one. That one's why that's not a grading. I didn't even think about it when I wrote it up there.
Okay, so
Pretty much any other number but 16.
you take the answer and that becomes your log. And then this one, your dividend. No.
We're not dividing, so let's not talk about this,
Okay.
not division.
Our root becomes this thing, comes over here, and then our answer is our cube.
I did it.
Hmm?
Can't do it.
No.
Well, I'm gonna just explain it in words. That's all I care about. Well, I mean, you need to know how to convert. This probably will be this will be one of the easier quiz questions. I'll probably give you something like these. And I'll say, write this in log notation, as long as you know where this stuff goes, not super challenging. So here's what I will say. When you are getting this information, you're taking the square root, the cube root, or whatever of that, right? Whatever's under the radical. Well, you take the log of that over here. So you're taking the log of the big number, just like you took the square root, cube root, whatever, the big number. Not called the base. I don't even know. I'll be honest. I don't know what it's called. The base
The
is
big
still,
number.
the base is still whatever number is being raised to a
How
power.
about the big number, the little number, and then your answer? That's how you know.
The big number, little number there. So the base is still the number that's like the subscript by the log. So the base would be 2. We're raising 2 to the 4th power, which gives us 16. So this becomes the exponent, this becomes the exponent, this becomes the exponent. So 10 to the 2nd power is 100. 5 to the 3rd power, oh yeah, I wouldn't think of doing here. Oh, so 5 to the 3rd power is 125. 2 to the 4th power is 16.
I was having fun facing that way, pretending to like hit your back and knees with the yards.
Yeah, I think that's funny.
I think it's hilarious.
So just remember where everything goes. If you need to, like, you'll have a calculator, just test on the calculator. Make sure you're doing it right. Make sure the numbers you put in the right spot come out to be the correct answer when you take a log of something.
Another whack. Right?
Yes. Wait, can you already go?
No, I asked to go
Oh,
just now. That's why I was standing up. I was gonna go to the bathroom and you told me to go sit back down.
oh, I did not hear. I mean, I heard you say something. I didn't.
Yeah, and you were like, I'm not keeping you up here.
So I'm not gonna do a whole, oh, let's see if some of those are problems in the book. I don't know if they even do, I mean, if they gotta do it, it's. Well, they're not, that's not really what the lesson is talking about specifically. Yeah, it's a little different, let's see, they probably have some. Yeah, so do 7 through 14. Those are be pretty simple, easy quiz questions for you. Remember, you can check the odd ones in the back. So if you're getting the odd ones correct, there's a pretty good chance you're getting all of them correct. If you're all the same that kind of page. 378. Actually, let me write. I haven't been writing the pages up. I gotta start doing that. So let's see, what color do I need? So 7 through 14. 378, 7 through 14. I need to still do the other pages. So I'll catch that board up over there like that. Natural base. Yeah, that's a weird thing. I'll go down. So 368, 21 to 24. And I mean, these are not exactly like what'll be on the quiz, but if you remember what we did, it should be good. 369, 45. 2. And then what did I just say for this lesson? Page, what was it, 3? That's pretty cut up. We do logarithm now. Ah. That was. There's really, don't forget about the direct variation, indirect variation on your last. Oh, hold on. Dude, this is still in there. Was that? Hold on, I'm trying to catch the board up and then I'll look at it. There we go. Yeah, that should be cut up. There's not really any examples for direct and inverse variation, but that's where you have to create the word problem scenario and write the equation for it. All right, so are you guys good? You want me to do one? Let's see, number 8. Oh, yeah, I didn't go over that. I'm sorry. So the way you actually, when you have we always assume for logs, it's kind of like we assume the exponent is 1 if there's not an exponent. We assume the root is a 2 if we don't see a 2. If it's a base of 10, then we don't write the 10. If it just says log of a number, like just log of 100, that assumes the base is 10. So in that one, you would just be assuming that the base is 10. So 10 to what power is 1000? So that's, now that should be pretty simple now. I meant to go over that. That's why the whole reason I put that problem with 10 at the bottom was because that. Yeah, if there's no base showing, then it's base 10. And that scientific notation uses that a lot. But the scientific notation is something, some number times 10 to some power when you deal with very large numbers and very small numbers. So yeah, they use logarithms a lot because of that whole concept, scientific notation. So did that, like, do you still need? You get 9? Yeah, Janelle, did you get 9? So if you need, we'll try to do number 9. I mean, you can check your answer, but try to do it, we'll go over it. Oh, yeah, okay. I mean, all you're really doing is taking that base, writing whatever's on the far right is the exponent, and saying equals three. For those, it's the one, the next one. Man, I'm good. So they did it more with exponents, it's not so much with radicals, but. Right in black, so. So that's all 3 different ways you could write those expressions. You need to know all 3. So with exponents and a base, with radical and a root, and then with log, which would also have a base. All 3 of those. They don't really use radicals, but they don't have that in. So now you can do some problems now that you kind of understand that concept from. Not gonna lie, I mean, I hope you can evaluate, you're just plugging the number in the calculator.
I said log 2.
Fun.
Right.
The top one?
Yeah.
Yeah, log 2 of 16 equals 4. So what you know that?
They all say log, right?
Correct. So yeah, you should be able to do 15 through 20. Add that in 15 through 20. For a way right into the calculator, I might skip it. Oh, you. I was like, that cannot be. Okay.
This is what Coach Crawford gave me.
Oh, that would be. Oh,
I love when the brain be in here.
if you come in here, you're not leaving early.
These are, I don't leave early anyway.
Well, like how you like to walk out before the bell rings. So that
Okay,
you
I
can
won't
get
walk out early today. Anyways,
Oh,
what
yeah.
are we doing today?
Log-
Bro, you know Z,
Yeah. that's-
she's only coming to watch.
What?
Yesterday she hurt her ankle at like real bad. But she's getting her fixed today too. So
All right. Luckily, she's come out a little bit.
but I'm coming today. But what?
So I'm gonna add a whole bunch of stuff. I'm gonna sketch. So I'm gonna add 15 through 32. Not sure what they're asking for on the 25 through 28. We'll have to look in the back, but so 15 through 32, I'm also adding to that. So all of this is potential Monday stuff. Oh, no. I didn't write the other stuff. 7, actually, I'm just gonna say 7 through 32. Come on. Anybody else that you know? Is Kiani still coming out? I put her name on the list.
We got spent.
There's only one left. All we got. No.
We got bread in here. Is this bread?
I just brought new bread. I had to.
So that's
bring some
bread?
new bread.
Ooh.
Yeah, I just brought that.
Do you have a spoon? Can I have some of your peanut butter?
No, you can't eat on my peanut butter.
Okay.
How are you gonna eat out of my peanut butter without sticking the spoon back in?
No, like it's just a scoop. And like,
One scoop. Yeah.
you know, good protein.
Oh, my God.
I used to eat more protein. Like I used to. It's
Yeah, no, I do that every once, not a lot, but every once in a while if I'm starving, I'm just super lazy. All right, so you're working on page 69, 7 through 32. I'll probably take requests in like, oh, I don't think I did 10 minutes. I'll take requests in like 7 minutes. So you may want to try some of the more difficult ones in there. I don't really think any of this stuff is super complex, so you should still be in pretty good shape for the quiz Monday. And again, keep in mind, because a lot of you are starting to tune out, you get one shot on Monday. There's no retakes Monday. So when you start to tune out, remind yourself of that. I know, right?
what time is practice in?
4:30. I mean, that's estimate. Oh, okay. I forgot my phone. I left my phone at home this morning, so I'm sure. Oh, actually, I told him to email me. Let me see. Okay. See, we'll free, not that you need that anymore, but we'll freeze that. I guess I can stop record. I'm gonna miss the problem if I do this. I guess I'll wait. After we do a project. That's the peanut butter in the pantry. Put a pantry in all you want. Hundreds of yards.
Fine, go get one.
I think they used to. I know when I went, they'd have just shells and shells of peanut butter. I've been in there. Oh, that's a troll frying. I don't know.
There.
The pantry, like they used to have a ton of peanut butter in the machine.
I just go.
They had like three different kind. It was all like basically the same thing, but they had like different label. And I'm like, it's just all peanut butter.
What's up? Yeah, I'll go
It's
this
like
way.
a lot of people tuning out over those tables.
Stack one, yeah.
Like when you get time to practice, I don't feel bad about it on Mondays when you take quizzes and you don't know what you're doing. We don't always get time to practice, so I'd be taking advantage of it. And we don't always have a fairly easy lesson. What's that? I mean, it'll probably be more, but there'll probably be more easy ones. Because I mean, the direct variation, that's not super tough. You're creating your own scenario and then you can do it ahead of time. I'm gonna write on there what you can't use though, so create one that's different from anything we talked about. Maybe the more specific, the better, in case we talked, because if we talked about it in seventh period, I'm also gonna put that you can't use it. Like you can't use hourly rate and wages.
Exponents.
So the exponent, well, that'll be, well, there'll still be one on the quiz. There'll be a more difficult one on the quiz where you have to change both bases to be a common
Only one.
base. What's that?
Only one battle.
Yeah, probably for that, because we're gonna do an exit ticket on that. It'll be a simple one. So
Oh.
on the quiz, it'll be just a little bit more difficult one.
And I'm guessing there's gonna be a lot more. questions.
Yeah, we'll do something on Thursday that will be there, more log stuff. Oh, there'll be an investment one like what we did before too, because I said one will be compounding annually, one will be compounding, semi-annually, quarterly, something like that. And then this, what you're working on right now. So we haven't really, like I said, I skipped a tough chapter. That module or chapter 4. If you ever want to go back and look at it, it was crazy. First of all, it required like high tech graphing calculator kind of stuff, which we don't have. But even without that, all the concepts were, yeah, probably not a bad idea to take pictures since you got a lot of problems assigned today. Take a picture of that page and then write down 7 through whatever.
Lots of stuff.
Yeah, we're gonna probably do more log stuff.
Like actual one.
Nah, I mean, the only thing I did is explain that like it sounds intimidating. It's really just a number, it's just a concept.
So what number?
7 through what? 32, is that right? Yeah, 7 through 32, I think. And I don't think any of it's like, I'm not saying it's all easy, but I don't think any of it's super complex. Like if you do a few of them, you probably should be in good shape. And we'll do, like I said, we'll do one in a couple minutes. So you may want to skip down to the ones that look harder, which is probably like 25 through 2. You may want to try those while we're in practice later class. Some of it's just using the calculator, so you can check those answers back in the book. Oh, I take a picture of the answers, by the way. Don't just take a picture of the problems, turn your back, take a picture of the answer, so you can try that on your own. Still think somebody took some books that I did. All that enthusiasm, yeah. Interesting.
Isn't you my,
It's what happens when you, see, this is why I don't get practice out there. So, we practice.
Give me my simplifying things, man.
Your answer is it?
Put it in another form. Which one are you on?
Your
25.
So what is like? It kind of means, what's the base in that problem? Like if we thought about it as an exponent, what's the base? We're raising what to what power to get it? See what I'm saying? So the answer is you're trying to find what the exponent would be on that base to get to the number you're taking from on. Ooh, that's a tough one. There's a rule for that. How many know the physics? We're just rewriting these. Afterwards, yeah. It's like 7, 9, 2, which don't typically like negative. It's fine. Yeah, these are just rewriting. That's why I said you may want to try these. Yeah, that's just rewriting it. So again, the ones that are rewriting 7 through 14, I mean, I'm hoping you can do those, and I might put one problem, but I'm not going to put tons of them. Make sure you try, what is it, 25 through 32. And I don't even think those are that difficult.
Okay, so for my 15. That makes sense.
I think it's the other way around. 2 to what power? Well,
Yeah.
they're telling you, yeah. So,
Two, what power is 60?
correct. Yes. Exactly. It's kind of the same thing, really. You're doing down here. It's not a little bit. It actually is the exact same thing you're doing up here. 8 to what power? 8. pi to what power is pi squared? 7.5 to what power is
25 plus 1.
Yeah. Yeah. So again, none of these are that bad. I don't know if they get way more complex in the chapter. I'll go back and look. But at least today's stuff on logs is not that bad. Ooh, the human memory model. Definitely not doing domain. We're not doing training.
Don't use all of them.
I don't think we're gonna do that. Yeah, we may be done with this long. I don't know if it's another long. Oh, yeah. Yeah, we definitely have to do the next chapter Thursday. That's a little more complex.
Next to the log.
Hmm.
That's your base.
I know I can get one of those two.
I'm more thinking of how buried you are in your following skill. I had the hand sanitizer. Oh, did you find it? Right, I was gonna say it was on my desk. I don't know what happened. Yeah. Just when you guys were starting to make your comeback too. Quarter had started out pretty good for a lot of you. Falling off the wagon.
Okay, so
We just gotta evaluate which will log of X at the value of 10.
and it's 3, right?
Okay,
So 10, so how are
I believe, and let's check it in the back, if it's just, this is gonna shit, but if it just says log of X, then that just means the base is 10. So 10 raised to 15, and again, all you're really doing is taking the log. But now let's go to the back. So that, what does that mean? You tell me what that means.
So all it's doing, so
Perfect. Into that power equal, so what power does 2 need? So let's see if that's what your answer is. Yeah, if they don't give you a base where it says log of this number, then they're just saying the base is 10. And most calculators don't have any other option. All you can do is base 10. And there's not another log.
and it's 64.
Yeah, it's 10 to the power of that log.
That's the extra base.
Now, it does have natural log.
Like you said, it's 8. So. Square height or square.
Yeah.
So just really, what number is that? That starts with section 21?
Yeah.
So on the section where 21 is, they're basically just saying your base is 10. So they just said log of X. Well, if there's no base, we said that means you're using a base of 10. But you're really just plugging it in and calculating. It's like using the log function to calculate it. Which that won't be on the quiz, I can tell you that, but I do want you to understand that if there's no base, then the base is 10. The answer that you get when you take the log of a number means 10 raised to that decimal, that number, equals whatever the value is that you took the log of. Oh, shoot, I was gonna do, does anybody have one they want me to do? Any of them that you kind of were stuck on or didn't understand why they got a different answer or? Yeah. Yeah, I won't be too bad in this, it should be Sunday, I think.
There's this one out there, but it's still at 3.
29 to 36.
Now let's do 32. I mean, again, that's not nearly as complex, I don't think it's nearly as complex as you think. Well, I guess we'll find out in a second.
16.
We just said we would do 32, which I do want to, because that's about the most complex thing I see. And then we'll come back to 16. 16 though. So that has to do with kind of converting a radical into an exponent. So I'll come back to that. I'll do that one too. What is the problem on 30, what was it, 32 we were doing? What's the problem? So what's the first thing we need to understand about that? Has to do with something that's missing there. What would I normally have in a log problem, or what did I have in most of the log problems on this page? Like when I say the log of something. I think it's still called the base, I'm pretty sure. We don't have the base, right? We don't have this little guy down here. So if we don't have it, what do we say it is? 10. So that's that's probably the big key, is that that's 10. So if I am now saying these two have to equal each other, what's got to be true? Kind of like what we did sort of first thing with exponents. 32. Yeah, if I've got a base here of 10 and a base here of 10, and those two things have to equal each other, well, then that x squared plus 6x has to equal 27. And I think, does that what it says, solve for x? And 1 to 1 just means what we just did.
Okay.
That if the base is the same, again, kind of like when we did exponents, if the base is the same, the only way the numbers are the same is if I'm taking that log of the same number. So 6x plus, so what do you think we have to do? Like, why did they all of a sudden throw a square term in there? How did we solve these when we were doing stuff with squares a long time ago? Yeah, you wind up factoring.
Yeah.
So you'll get a couple answers. So you have to, I'm assuming it can be factored. If not, I wouldn't give you something that can't be factored. So on my quiz, you'd be able to factor it. They taught other ways of solving, like completing the square, quadratic equation. We didn't do those, so I'm not going to give you something that. Yes. Yes, you are. So let's see if you can factor that.
Yes.
Dan? I would think you could. I'm trying to. Oh, actually, I set up off now. Yeah, this would have been a while. Did you guys take PSAT this year? Some of you I know would have, but. So what did you get as your value?
What is that for?
So do this. Boom. Factor that out and solve it. I can't wait to come out and watch tomorrow.
Isn't it 15 umpires? That's an umpire mistake.
They're training or for something practice. Yeah, we got flag until. We got flag until 4:30ish, and then we'll probably have to talk with coach a minute afterwards, and I should have my dog with me already, so I can do a rush home. So just drive around. And park.
Got it.
Get it? Got it? Good.
No, go back down.
I
Killer.
don't know that it's right yet. Let's see what you got. How about this? Didn't get it right. I get it.
No.
Not that confident. You're pretty confident. You're never that confident, huh? You're not lying.
I did it.
You gotta give me the answers. I want to know what X is.
I did give you what X is. It's right here.
I just
Tell
saw
me
back.
what I needed to write down. Oh,
Yeah, good thing you didn't make that promise about phones, huh?
there you go. Got it.
See, that looks good. I believe that looks good. All right, let's go. Oh, yeah, wow. So remember, when you factor, you focus on the leading term, the x squared, whatever the x squared term is. Only one way to get that in this, x times x, so no options. Now I just focus on -27. There's a few ways to get that, but since we've done a bunch of these, we probably can guess 27 and 1 is not the way we want to go. Not really any other factors besides 9 and 3, right? So pretty sure those are going to work out. Now it might not be a bad idea, instead of just plugging a sign in, to say, well, I need a positive result in the middle. So let me make the 9 the positive and the 3. So that's not super difficult. I feel like that's something that you should be able to do. The only challenging part is going to be, we haven't had a quiz in a little bit longer period of time. So there's going to be a little bit more on this quiz. So just keeping it all straight is going to be the only relatively tricky part.
I like this. You can see.
I saw you working there. See, not that bad, is it?
I'm like, yes, it is.
Guess that. Yeah.
What's that mean? I am slower than Rachel today. Rachel was up to one. I'll just be honest.
I was on and off. I want to play.
Don't want to quit?
No, I hate it.
No. Wait, what is this? The violin? You're the one that wanted to do violin. That was your own fault. Your own fault. Just think of how cool it'll be once you know how to play it. Right, Janija? Right? Right? Huh? Right? Right?
I'm gonna go and tell my dad I did my math. On my team. That's so weird. For sure. What's up with it?
Oh, did I stop? I didn't stop the recording.
I knew my.
You better know this stuff.
I don't.
I knew my.
You do not get an extra retake on this, girl. And this would kill your
It
grade.
probably will.
Because you did nothing. Well, you answered one sample.
Well, I didn't know what y'all were talking about. Can I come in during the third period? Can I come in during the third period?
For what?
For you to tell me how to do it?
No, I'm not gonna let you tune out, be on your phone, and me do a whole lesson during my free time. You're on your phone all the time. We didn't do anything yesterday.
Earlier,
I did.
Oh, that was new.
Yes, today. We did that today. The only thing that was new was the original, or I'm sorry, old was the original export problem. I'll see you in an hour, which we went over how to do it.
The
Like
extra-
changing the 27 to 3 cubed and then figuring out.
That was
Setting
easy.
I know, so don't claim that you don't know how to do the stuff because you weren't here, because you do know how to do the stuff.
I don't do that one thing.
It will be one question.
Yeah,
But your
one-
exit, but your exit ticket is also on that, so that'll be a whole ring on its own, and then on the regular one.
Do anything for you.
Sure it does. It does when the big quiz is only 4 points. No, you're taking my time up. Then you should have paid attention.
That sucks.
Why did you not pay attention?
Cause I'm not doing that.
You're not paying attention?
I'm not doing that.
Girl, that was brand new for everybody.
When I went to the bathroom, this he walked by and he did like a double back and he was like, I want you. Like,
Why did you do that?
I don't know.
You said Mr. P?
Yeah,
Oh, that's fine.
'cause now he has plans.
Oh, gotcha.
Because in the first semester, they give you 2 reading classes for the seniors that haven't gotten a reading credit yet. And then they either pass it, but then like most of them pass it because it's like dumbed down, like really easy. So they can do it. And then second semester, they give him critical thinking, which is for the kids that can't pass math.
Yeah, no, I know those kids.
And then he gets a planning period, intensive period. Oh, yes. Do you like my Buffy blanket?
Yeah, you have the pants too, right?
And shorts, which I now realize are not shorts. They're.
You'd think by now I would have hit that stop. Oh, you know what? I am hitting it. It's just I just noticed the red marker is not on there. So it's not. It's just making red marks on it. There we go.